We are given the information about a bacteria culture and asked to answer these 4 questions. It says the count in a bacteria culture was 400 after 15 minutes and 1700 after 30 minutes. Assume the amount of bacteria grows exponentially and find the following. So because we know it grows exponentially, or we're told to assume that, we would be using the exponential interest formula or exponential growth formula. The most common form of that formula is A, which means your future amount, is equal to P, the principal or present amount, times the natural number E to the power of the rate in decimal form and times time. So this can be presented in different formats with different symbols, but it's always the same basic meaning. So first we're asked to find the initial count of the bacteria, which would be your present amount, P. Okay. So if we take this formula and solve it for P by dividing e to the RT on both sides, we get P equals A, the future amount, divided by e to the RT. And now I have 2 sets of information that I can use to make 2 versions of the P amount with respect to the information given. So A over e to the RT for the first set, 400 after 15 minutes, becomes 400, the future amount, divided by e to the power of 15 times r. So 15 would be the minutes. So here time will be expressed in minutes. Depending on the problem you're working on, your time increments can be different. For instance, if you're talking about investments, it's usually time in years. But as long as you keep all your units consistent, it should be fine. So I just made sure to make everything in minutes. So T represents the number of minutes. So I have 400 divided by e to the 15r equals, and then P also equals, for the second set, 1700 after 30 minutes is 1700 divided by e to the power of 30r. Now, because these both represent P, they can be set equal to each other. And then you can solve the proportion by cross multiplying. So you see here that I have cross multiplied 400 times e to the 30r on the left side here, and cross multiplied 1700 times e to the 15r on the right. Continuing from there, I got all my e's on the same side by dividing e to the 15r. And I did that on both sides. So now it canceled from the right, and now it's on the left in the denominator. And also I divided by 400 on both sides. So now I have this. E to the 30r divided by e to the 15r is equal to 1700 divided by 400. From there, because we have the same base in our exponential expressions, we can subtract the exponents, and we end up with e to the 15r on the left. And the 1700 over 400 can simplify down to 17 divided by 4. And 17 divided by 4 is exactly 4.25. So I went ahead and wrote it as a decimal since that's easier to carry around, and I'm not having to round it, so I don't have to worry about round off error. So then I take the natural log of both sides, because what I want to do is release the 15r out of the exponent level. So by taking the natural log of both sides, then I'm able to use the power rule for natural logarithm, or for logarithms in general, where 15r came in front of the natural log of e. The natural log of e is just 1, so that pretty much cancels out. And then you end up with 15r equals natural log of 4.25. Then dividing 15 on both sides, I get r equals the natural log of 14, say that again. R equals the natural log of 4.25 divided by 15. Now, all of that was important because I initially had 2 unknowns going on in my original version of what I wanted to solve. I had P and I had R both unknown. Now, what we're trying to find is P ultimately, but by finding R, we can use it to unlock P. So this is really a system of equations type of thing where you're doing substitution. So now I'm going to go on to the next step, using that R value, which is now, it looks pretty crazy, but it is just a constant value now. And so now I can plug that back into one of the original versions of the equation up here, P equals 400 over e to the 15R, or P equals 1700 over e to the 30R. If I plug R into one of those equations now, I'll know what P is. I'll have it as a constant. So in the next side here, I've written P equals 400 over e to the 15R. Then I replaced R with natural log 4.25 divided by 15. The 15 here and here cancel. And then I have a simplified version, P equals 400 over e to the natural log of 4.25. And that, when you calculate it, is approximately 94.12. And that is the answer to A. So this is a very involved problem. This is probably one that, if this explanation doesn't help, you probably want to walk through this with a tutor or come to my office hours, because we've just now completed one part of a 4-part question. So let's go on and see how the next one goes. The next one says find the doubling period. Okay, so when your bacteria will double, when will that be? How long will it take? In other words, you're going to ultimately want to solve for T. But you use the fact that they're talking about doubling. And that means that in general, your future amount will be equal to twice the principal or present or beginning amount. Now, knowing that, I can simply take this equation here, A equals P times e to the RT, and replace the A, the future amount, with 2 times P, as I've done here. And then notice I canceled out the P's, because if you divide P on both sides, they'll cancel out. So then that simplifies to 2 equals e to the RT. I know what R is, but I don't know what T is, but that's ultimately what I want to get, right? So I know what R is. It's natural log 4.25 over 15, but I'm not going to plug it in yet. I'm going to solve for R first. Or actually, I meant to say I'm going to solve for T first, and then at the end I'll plug in the value for R, just because it's a lot to keep writing over and over. So if I keep it just R for now until I have solved all this for T, it'll be a lot easier on me. So first of all, to get the RT down out of the exponential level, I took the natural log of both sides. And then on the right, the E and the natural log part cancel out. So then I have the natural log of 2 equals RT. Then, since I want to solve for T, I'm going to divide both sides by R so I can get T alone. So then I have T equals the natural log of 2 divided by R. Finally, I'm plugging in the value of R, which is the natural log of 4.25 divided by 15. And then I will calculate all of this together to simplify it to approximately 7.19 minutes. Remember, T is in minutes. So it should take 7.19 minutes for the starting amount to double. And if we check back to what they told us in the beginning, the bacteria amount was 400 after 15 minutes and 1700 after 30 minutes. Then we figured out that the principal amount, the starting amount, was 94.12. So if you double that, that would be an amount that would lie somewhere between 400 and 1700. So having an answer, oh no, I didn't say that right. Let me say that again. If you double this, it would be, let's see, 188.24. So 188.24 is less than 400, so it should be less than 15 minutes that it takes to double. That's what I meant to say. So 7.19 minutes seems like a reasonable answer. That was part B. Moving on to part C, it says the population after 75 minutes. Well, now that I know the principal amount and I know the rates are, I can plug those in and to this formula here and find the future amount after 75 minutes. So I've replaced the P with 94.12. I've replaced the R with natural log 4.25 divided by 15. And I replaced the T 75 minutes and then just evaluated that with a calculator to get 130,504.83. That's part C. Finally, part D. When the population will reach 14,000. All right, so, oh, I just realized I made a mistake here. This should say 14,000, not 1,400. So let me make an adjustment. As I was saying, and now I've fixed my typo and I had to make a couple other fixes. And I noticed that when you were using, I used the rounded version of P to do this calculation. And the whole time I was thinking, this is not a good idea. You really shouldn't model this. Using a rounded value, especially when natural logs and exponents are involved, can result in a very wrong final answer, not because your calculations are off, but because you are using a rounded value. And literally that round off error is getting exponentially increased. So I did use the rounded version. And when I first went through this and I got the wrong answer, it was way off. And then I figured out that if I just included 2 more decimal places from that original answer, it ended up giving me a much different answer and an answer that was correct. So here's what I did. Just good rule of thumb, try not to use rounded values. If you do use a rounded value, include as many decimals as possible to minimize round off error. For this particular question, 4 decimal places did the trick, and in many cases that is true, but again, it's better to use the whole value without rounding it. Your calculator will usually have a store button where you can have certain values stored into a variable and use it in your calculations. So I started with, it says, when will the population reach 14,000? So I took this formula, A equals P times e to the RT, and I put 14,000 for A, for the future value, and equals 94.1176 for the present value. That's coming from part A. Then e to the power of natural log 4.25 divided by 15 and times t. Then I simplified some things and divided both sides by 94.1176 because ultimately I'm trying to get t alone. So the first thing I did was divide both sides by 94.1176. Then I have e to the t times natural log 4.25 times divided by 15. All I did was switch the order here, which you can do with multiplication. And then I took the natural log of both sides to release the t from the exponent position. Taking the natural log cancels out the e on the right. And then I end up with natural log 14,000 divided by 94.1176 equals t times natural log 4.25 divided by 15. Then now I'm going to multiply by the reciprocal of this fraction so that I can get t alone. So multiplying by the reciprocal on both sides, eventually t was equal to all of this, natural log of 14,000 divided by 94.1176 times 15 divided by natural log 4.25. And so this ultimately gives you your final answer, your answer to part D, when rounded to 2 decimal places, is 51.86. So I know that was a lot. Again, if you would like to discuss it, come over to my office hours and or go to see a tutor.